Oh, there we go. I'm live. But yeah, they couldn't just be like, hey guys, I know it's been a rough year. I know it's been like crazy for everybody. I know that everyone's kind of like, stressed to the ends of their life. Like everything is just so crazy. So let's have a snow day. Psych. Nope, you're going to school. Oh, 2 days in a row? Cool. And then I wake up this morning and my car is an ice block, but I have to get to work on time? Cool. Oh, and my glasses broke? Cool. My daughter broke my glasses. She's 2, but I hold her accountable. It's coming out of her Christmas money. It's not. Come on. Yes, it is. Now, oh, goodness gracious. It's just been one of those days. I'm giving people an opportunity to get into the chat, and then we'll get this thing moving. Goodness. Okay, where am I? I'm here. For those of you in the chat, if you have not already left a comment, please do so. That would be great. That would be fantastic. I had you guys Monday? That was Monday, wasn't it? Oh, snap. That was great. Anyway, we're going to continue with what we were doing on Monday. We're going to continue with some problems. We're going to get this thing done. Can I tell you that if I have to live stream, just be honest, is my setup better here or is my setup better at home? Right? Come on. No, not for you guys. Don't worry about you. Imagine that you actually still had to come into school. Imagine that you still had to be in this desk. My setup is still better at home, right? Just saying, it is so much better. I can flip between websites. I can transition. I can do a webcam shot of me. Hey, was this the class that I showed my daughter? What? It was? Nobody commented on her. No. Did I show her like actually in person live? Oh, okay. Cool. No, you commented on my daughter's picture, right? Yeah. All of you are dead to me. Except you. Wow. Okay, cool. Oh, goodness. All right. So if you haven't left a comment, please do so. And if you would, ladies and gentlemen, we're going to get this thing rolling. I'm going to need those notebooks out and open. Let's do it. Whoa! Okay, no one's excited. All right. Oh, the excitement level's draining here. I have to read you a story as to what happened to my wife this morning. Oh my word, this is long. Okay, I'm going to read this just as is. Y'all ready? Here we go. My wife texted me, a morning event as it played out. I'm in the bedroom. From the other room, Ellie is calling to me. Ellie is our 2-year-old daughter. She yells, I just spilled salad. Mind you, this is like 9 a.m. I just spilled salad. And my wife yells back, what? How? And she yells back, my salad smoothie. My wife says she made her a peanut butter smoothie with spinach this morning, which, by the way, are actually really good. And there was leftover smoothie in the fridge. My wife yells, why did you get it out of the fridge? She finishes up and comes out, and my daughter was apparently rummaging in a cabinet. She found the spilled smoothie on the floor. She had spilled it everywhere. But oddly, the cup was missing. Was it in the blender? But the blender wasn't there either. Where's your smoothie cup? It's in the fridge. Where did all the smoothie come from? From my belly. It was yucky. I spit it out. Sure enough, apparently she vomited all over the kitchen floor. And she said that she spilled her smoothie. Oh, gosh. None of you find that hilarious? Whatever. Goodness. Some of you are like, oh, that's the grossest thing I've ever heard. And I'm like, well, wait till you're a parent. That's not the grossest thing you've ever heard. Oh, goodness. I hope she's not sick. I guess I shouldn't go home then. Anyway, let's get started. Where's my paperwork? There it is. Last class, I had posted into the Google Drive 2 PDFs because, well, I wasn't obviously able to make copies of them, but there were 2 PDFs there, 6.5 and 6.6. There are certain problems from that worksheet that I chose to review, and we did, and it was fantastic, and I high-fived myself. I would like to continue with that. I would like to continue with this process. This process of simplifying radicals is going to be important soon, very soon, because once we get to the very end of chapter 6, you're going to see the types of problems that I'm referring to that are going to be very important. But let's call this simplifying radicals continued. Let's call this simplifying radicals continued. So I want to start with a very basic example. It's actually number 4 off of that worksheet. And it is the 4th root of 405. Let me zoom in on that. The 4th root, I'm sorry, the negative 4th root of 405. Oh, there it is. It needs the focus. Come on, little thing. A little better. Okay, worse. There we go, better. Although I have my glasses off, so. Okay. What I taught you on Monday was to look at this number, 405, and start by breaking this thing down as far as it can possibly go. And what I mean by breaking this thing down, I mean breaking it apart like a prime factorization, like a factor tree. So I'm going to go to my calculator. Here we go. Boop. And I'm going to do 405. Now, I can't divide it by 2. I can't divide it by 2. Clearly, it's not going to be divisible by 2. I could try 3. I could also try 5. Let's try 5. Yay, it worked. I can't do 5 again. Let me go back to 3. I never tried 3. Divide by 3. Oh, divide by 3. Divide by 3. Divide by 3. Ah, I didn't type in the 3. There we go. Interesting. What I just showed, and I'll confirm this on the calculator in a moment, but what I just showed was that the number 405 could be broken down in the following way. 3 times 3 times 3 times 3 times 5. I broke it down as far as it could possibly go. Yeah. High fives. Let me confirm that in the calculator. 3 times 3 times 3 times 3 times 5. Boom. 405. Yes. It worked. Now, why that's important is because we have a 4th root. Ms. Markey, what do we do with the negative? Just leave it. The negative is out front. In fact, that's not just a negative. That's a negative what? That's a negative what? Ooh. It's actually a number. What? Nah, yeah. You assume it's a negative 1. Let's just leave it there. It's not doing anything. It's not inside the radical. It's just hanging out front. It's a negative 1 times the radical. Just leave it there. For now. But we have a 4th root. The only way that you escape a 4th root is if you have a 4th power. In order to have a 4th power, well, we do have one of them here. This is 3 to the 4th power. That is 3 to the 4th power. So I can take that 3 to the 4th power, and it is allowed to escape the radical. Now I'm going to take a longer approach to this just to kind of show you what happens here. That negative's out front. I'm going to take a longer approach here just to kind of show you what the heck is going on. The fourth root of 3 to the fourth times the fourth root of 5. Cool. Well, I know that I'm going to put this in red, actually, so you can see it here. This fourth power and this fourth root cancel each other out. Yeah! And since they cancel each other out, that leaves me with the 3. Yes, it does. Now, mind you, that radical symbol is a part of that little 4. That radical symbol and that little 4 are one and the same. They cancel out with that exponent of 4. What we are left with, negative 3, fourth root of 5. That is the simplified answer to this particular problem. It's kind of a nice problem. It's kind of a straightforward problem. This is what we did on Monday. We're going to build upon this. I'm going to give you more techniques. I'm going to give you more challenges, things of that nature. But I want to see what you can do with it first. Let's try another one. I want to take a little bit of a shortcut on this one. But we'll see. Zoom out. This example is actually number 5 off of that worksheet. Oh, there it is. Zoom it in. Okay. Now, number 5 is the third root of negative 5,000. Ooh, I don't know about that negative. Now, we'll deal with that negative next time. We'll deal with that negative in a moment. We'll figure that negative out. Ignore the negative for now. Look at the other number. Look at the 5,000. Now, if we wanted to, we could break down that 5,000 in the same way that we did all these other numbers. We could do that. I don't feel like doing that. So I'm going to ask you this. What 2 numbers multiply to give you 5,000? What 2 numbers multiply to give you 5,000? Any 2 numbers. Come on, you can do this in your head. It's a very straightforward type of number. I don't know. Who taught you math in middle school? To which I asked that. Most of you chuckled to yourself. And you're like, middle school? I don't remember math from middle school. Wow, 5,000. How do you get it? Mm-hmm. We do this the easy way or we can do this the hard way. The easy way is you figuring out what 2 numbers multiply to give you 5,000. The hard way is doing what I'm about to do. 1,005. Yes, that's the easy way. Let me show you the hard way. Now, I'm not going to write down the hard way. I am not going to write down the hard way, but let me show you what the hard way would be. Here's the hard way. 5,000 divided by 2, divided by 2, 2, divided by 5, 5. So it's like 1, 2, 3, and then 5 times 5 times 5 times 5. And I have to write out all of those 2s and all of those 5s. Yeah, you could do that if you wanted to. Or you could recognize 5 times 1,000. Now, that's the easy way, in my opinion. But here's the big question. Why? Why is breaking this thing up in the following way? Watch this. Why is it breaking this thing up like this to be 1,005 into separate radicals? Why is that considered the easy part? What type of root do we have? type of root do we have? No, we don't have. It's a cube root. Do you guys know any perfect cubes off the top of your head? A number that is a perfect cube number? Oh, okay. I'll give you the easiest one. 1. 1 is a perfect cube because 1 times 1 times 1. Can you think of another perfect cube number? What's 2 times 2 times 2? I got the right class. This is math class, right? Yeah. 8's a perfect cube. You should know 3 times 3 times 3 off the top of your head. After that, it gets a little dicey. But do you know 3 times 3 times 3? 27. 27 is a perfect cube. 27 is a perfect cube. The reason why breaking this number up in the way that she said as 1005, the reason why this is the easy way is because this number is a perfect cube. The number 1000 is a perfect cube. 10 times 10 times 10. It's a perfect cube. If you can recognize a perfect power within that radical, if you can recognize a perfect power within that radical, then you are in much better shape than having to break that number down, as I talked about before. This, what I have written down, is the easy way. Doing this, 2 times 2 times 2 times 3 times 3, or 5 times 5, 5. Yeah, doing that is not the easy way. That's the long way. This is a nice shortcut because the cubed root of 1000 is nothing more than a 10. I can prove that right here. Math, cube root, 1000. There's the 10 right there. Perfect cube. The cube root of -1, as we talked about on Monday, is nothing more than -1. Because, well, -1 times -1 times -1 is -1. So, -10, third root of 5. Sometimes you can figure out the easy way. Sometimes it's obvious. And if you can recognize the easy way to get these problems done, it's just going to be so nice. Sometimes you can recognize them, and sometimes you can't. The fifth root of -1215. With -5000, that one hopefully should have been fairly straightforward. Oh, 5 times 1000. 1000 is a perfect cube. Yes. Nice. 1215. I don't know that many people that would figure this out off the top of their heads. I don't. Not many people would. Ugh. And if you're stuck, and if you don't know how to handle the number, and if you don't know where to go with it next, your best case scenario is breaking this thing down as far as it can possibly go. Sometimes it's going to be pretty straightforward in the calculator. Sometimes it is not. Click. Let's see. 1215. Clearly, it's not divisible by 2, but oh yeah, it's divisible by 5. 243. Now, unfortunately, you guys don't have the same number acumen that I do. I know what 243 is. I know how special 243 is. What can you divide 243 by? Ooh. Do you guys know the rule for 3? How do you know if a number is divisible by 3? Did anyone teach you this back in the day? Add up the digits. What is 2 plus 4 plus 3? What is 2 plus 4 plus 3? Is that divisible by 3? Then 243 is divisible by 3. That's actually the rule for 3. No one ever taught you that? Oh, snap. You know the division rule for 2. Obviously, if it ends in an even number, it's divisible by 2, right? If it ends in 0 or 5, it's divisible by 5, correct? Yeah. The rule for 3 is you add up all the digits, and if the sum is divisible by 3, then the whole thing is divisible by 3. There's actually a rule for 4, there's a rule for 6, there's a rule for 8, and there's a rule for 9. You know the rule for 10, right? Come on, what's the rule for 10? How do you know if a number is divisible by 10? If it ends in 0, yeah. There's actually a rule for 11 too, but I won't get into that. That's a fun one. Anyway, to this. Divide by 3. 3, 3, 3, 3. I divided it 1, 2, 3, 4, 5 times. 3 to the 5th power is 243. 243 times 5 is 1215. It doesn't take that long to figure out how to break down the number 1215. It doesn't take that long. So I can take that number 1215 and I can break it up like this. Let me zoom in on that. With a calculator, it should only take you a matter of moments to break a number like 1215 down as far as it can possibly go. It should. You could take any number and do that. From here, the answer is -3, 5th root of 5. We need to be careful with these types of things. Here's what I want to do. I want to give you, yep. Which portion? Oh, going from the second line to the third line? Okay. The 5th root of 5, first of all, I can't do anything. So it just came straight down. Done and done. The 5th root of -1 falls into the same category as the 3rd root of -1. Because I'm going to count it now. -1 times -1 times -1 times -1 times -1, -1. So that negative just came down as a -1 times the rest of the problem. I don't want that marker. I want the orange one. There it is. Here it is. 1215 broke down to 243 and 5, which 243 is actually 3 to the 5th power. The 5th power and the 5th root mutually cancel each other out. It's very strange. It's a similar situation if you had the square root of 16. Now, the square root of 16, you know what the square root of 16 is. It's 4. I just wrote 16 in there. Doesn't look like it, but clearly, but 4 squared is 16, right? The square root and the square mutually cancel each other out. The square root of 16 is equal to 4. It's the concept of inverse operations, and this is for everybody. If I needed to cancel out a number that was like +3, how do you cancel out +3? How do you cancel out a plus 3? With a minus 3. They're inverse operations. How do you cancel out times 5? Divide it by 5. How do you cancel out a fifth root? You cancel it out with a fifth power. They mutually cancel each other out. It's very strange. Sorry, do you all see my glasses like keep rolling forward? They just fell again. It's my daughter with her vomity tummy. Gosh. Oh, goodness gracious. That was great. This whole day. I think in like first period, I was trying to fix my glasses and then my watch broke. It's been a day and a half. Anywho, it's... Now, I want to give you a little bit of a challenge here. And this, not really a huge challenge, but this little bit of a challenge is going to exemplify some of the things that I just talked about. Bless you, whoever sneezed next door. Here's the problem. I'm going to give you a few minutes to try this. This is actually example number 10 off of that worksheet. Square root of 45 x cubed y to the 8th. Oh, Mr. Markey, you're throwing variables at us? Yes, I'm throwing variables at you. Why? Because we've done variables before in this. The variables act the same way that numbers do. It's just that you don't know what that number is. The x cubed is nothing more than x times x times x. The y to the 8th is nothing more than y being multiplied by itself 8 times. I want to see what you can do. This problem is a combination of what we've done today, what we did on Monday, and what we did a little bit before midterms. I want to see what you can do. Take the next minute or so and do whatever you can to this problem. Do whatever you can. Simplify it down as far as you believe it can go, and then I'm going to review this one. Take the time. Let's do it. All right. Let's see what I can do with this. Now, at this problem, first thing that I would attempt to do is to break down this 45 as far as it can go. Now, it's a square root, yes, but let's just see what we can do with that 45. You can break down that 45 to be 9 times 5. And of course, that 9 breaks down 3 and 3. But that 9, unto itself, that 9 is already a perfect square. Because remember, we're dealing with a square root here. So if I were to break this thing down, let me just break it down like this. 3 squared times 5, which I already know that 3 squared is 9, which I'll deal with in a minute. I'm going to take that x cubed, and I'm going to break that x cubed up. Because since I'm dealing with a square root, I believe the best way to handle it is to break that x cubed up to be, well, x squared and x to the first. Because then I can get something to escape. That y to the 8th, remember, is 8 y's being multiplied together. Well, I can break that up, actually. Y squared, y squared, y squared, y squared. Move that over. There we go. Because that would give me the 8 y's that are being multiplied together. That's y to the 8th power, according to the exponent properties that we've had in the past. Ultimately, I'm going to put certain things in parentheses here. That 3 squared now has the proper exponent. This x squared now has the proper exponent. So does this y, this y, this y, and this y. They all have the proper exponent to be able to cancel out that square root. The only way you cancel out a square root is if you have a perfect squared exponent. Now I'm going to draw some arrows in a minute. Just to show you where certain things went. Now, this is not my final answer. I'm going to write down my final answer in a moment. But notice right here, this 3 squared. That 3 squared now comes out as a 3 because the square and the square root canceled each other out. This x, same deal with this x. That x squared and that x, the squared and the square root cancel. And the same thing with all of these y's. They all came down to just be a y. They lost their exponent. What was left over, the 5 and the x left over, sorry, sucks to be you. You are not allowed to escape the square root. Thus, you are still inside of it. Ultimately, the final answer is this. There is more than one way to do this problem. There is always more than one way to do a problem. Always. This is just one of those ways. Regardless of which way you end up doing the problem, this, what I circled, is the answer that we all should be ending up with. Let me change it up just a tiny bit now. Change it up a tiny bit just to kind of show you what we can do here. There we go. Now I'm going to take some time kind of describing what the heck I just wrote up here. What I've written up here, 2 parentheses being multiplied together. And inside said parentheses, inside the parentheses, you have multiplication happening over again. It is 2 times the square root of 24, and it is 7 times the square root of 18. Regardless, everything is being multiplied together. There is only multiplication as one of the 4 major operations. There's no adding, there's no subtracting, just multiplication. Furthermore, I would hope that you would recognize that both 24 and 18 are not perfect squares. They are not. There's an easy way and an alternative way, kind of more difficult, to handle said problem. I want to show you both. Let me show you kind of the straightforward way that you could handle this problem. There's step 1. Now, this is not my answer. This is not my answer, but this is step 1. What did I do? I multiplied everything together. I multiplied everything together within the common form that they are. For example, 2 and 7. 2 and 7 were acting as coefficients on the front of this problem. 2 times 7 clearly gave you that 14. Yeah. But now here's the deal. When you have a square root times a square root, and I want to kind of, not visualize, but kind of give this example of it. When you have a square root times another square root, you are allowed to put them together if the operation is either multiplication or division. Let me repeat that and then add to it. If you have a square root times a square root, you are allowed to put them together into a single square root. Only if the operation was multiplication or division. You are not allowed to put them together with addition and subtraction. 24 times 18 gave you that 432. Now, I'm not done yet. Man, 432. I feel like we've seen 432 before. Have we seen 432? I guess not. Maybe I skipped that problem. Whatever. Let's do a 432. I got to break this thing down. 432. Calculator. Divided by 2. Divided by 2. Hey, did I do that devil's number thing on Monday? Okay. Good talk. All right. Divide by 2. Divide by 2. Ah, there we go. I was able to divide by 2 4 times. Let me divide. I can't divide by 2 anymore. Crap. Oh, but it's the number 27. What's so special about 27? Nobody remembers. Sadness fills my heart and overflows like my daughter's stomach onto the floor. Good?
Divided by 3.
Yeah. And I can do it 3 times. It's a perfect cube. You said that earlier. Yeah. Like my daughter's stomach. Anyway. It's a perfect cube. I can divide by 3, 3, and 3. So, this thing right here is actually equal to 14 times the square root of 2 times 2 times 2 times 2 times 3 times 3 times 3. So, it's a square root, meaning and ha and ya. I'm allowed to pair all of those together because those would make me a perfect square. 2 times 2 is 2 squared. 3 times 3 is 3 squared. Perfect squares. And as a result, they are allowed to escape. And unfortunately, this last little 3 cannot. That last little 3 cannot escape the square root because it did not have a partner to match the exponent that it needed in order to escape. I can multiply together the 14, the 2, 2, and 3. To get the answer I was looking for, which is 168 root 3. Now, like I said, there is an alternate way of doing this. I'm going to show you the alternate way in a moment. Unfortunately, the calculator is not going to do this for you. The calculator will only take it so far. 2 times the square root of 24 times 7 times the square root of 18. It'll just give you the decimal, unfortunately. I've seen people do this in the past where they type it into the calculator and they hit like math, enter, enter, and they hope for the best. It doesn't work. But my number works, clearly. 168 times root 3. Let me show you the alternative way. There is always more than one way to do a math problem. Have you ever heard the phrase, there is more than one way to skin a cat? Have you ever thought about how disgusting that is? Okay, great, good talk. Here's an alternative way of looking at it. Alternate. Oh, Mr. Markey, my mind is still on a snow day. Good for you. My mind is on everything else. So, here's the alternate way of looking at this thing. First, notice what I just did here. Instead of multiplying together the 24 and the 18, instead of doing that, I decided to keep them separated. Because sometimes you can do stuff like that, and it helps you in the long run. And in fact, it might be a tiny bit faster because you're not having to break down the number 432. Instead, keep them separated so that you can continue breaking these things down as far as they can go. Then, recognize the following. The fact that 24 holds the number 4. It's 4 times 6. And 18 holds the number 9. 9 times 2. So 4 times 6 times 9 times 2. The reason why that can be helpful is because now I've identified 2 perfect squares already in the problem. And I've never had to touch my calculator once. I didn't need to know what 24 times 18 was because I kept them separated. 24, I know how to break that down. 18, I know how to break that down. These 2 numbers are perfect squares. Why not take them out now? All right. 14 times 2 times 3 times the square root of 6 times 2, which I could make a 12 right now. I could. I will do that in a moment. You could figure out in your head that 14 times 2 times 3 is 84. and then you can break down that 6. This is just an alternate way of looking at the problem. An alternate way of looking at the problem. It gets you the same answer. I don't need you to know every single possible conceivable way to do problems like this. I need you to know a way that works. I need you to know a way that you can replicate with any problem that you want. These problems are strange. These problems are going to be a little bit tedious sometimes. But it's just the way that we can do them. Come on, little paper. There we go. Yeah, I'll get you in a minute. There we go. Let me show you. Let me show you one more problem that I want you to try. We're going to try one more problem today. One more problem today. And I actually want you to try this one on your own. This is number 16 off of that same worksheet. I want you to give this one a try. I want you to break this down as far as it could possibly go. Now, I'm going to tell you, technically, you don't really need a calculator for this. Technically, you don't really need a calculator. But if you wanted to use a calculator, by all means, you can. But I'm just saying that it can be done without it. Take the next couple of minutes, knock this problem out, and we'll review this one and wrap up today. I'm pretty sure there's no one going to be out there. I'm pretty sure no one's going to be out there. Yeah. If they are, then I'm going to blame you. Let me show you the ways you could handle this problem. There are several distinct ways that you can go about it. First things first, since everything's being multiplied together, you could bring everything together like this. I'm going to try and not use a calculator as much as possible. 3 times -4 gave you that -12. What's that -12 going to do? That -12 is just going to sit out front for the time being and just hang out there. It's just going to stay. The 15 and the 45 are what I'm really interested in because I have to simplify those things down. So I know that 15 is just going to be 3 times 5. And I know that 45 is going to be 9 times 5, which 9 is a perfect square. Good. That 9 can escape. That 9 escapes. Square root of 9 is 3. So this really should be -12 times 3. Square root of 3 times 5 times 5. Now again, I'm not done yet. I have to multiply the -12 times 3, which gets me what? A -36. But also, the 5 times 5 is a perfect square as well. As a result, that 5 is allowed to come out. Now, I want to show you kind of the flow chart as what's happening here as things are moving around. I will show you that little flow chart that I got going on here. I'm going to write it in red. But then -36 times 5 don't need a calculator to figure that out. It's -180 times the square root of 3. Where did everything go in this problem? Watch this little flow chart that I got going on here. First of all, the 15 and the 45 clearly just came down to the same square root. The 3 and the -4 multiplied together to give you that -12. Notice that -12, all it did for the remainder of the problem was hang out front until it was ultimately multiplied by constants. The 15 was broken apart. The 45 was broken apart. But then ultimately, that 9 was a perfect square. And because it was a perfect square, it was allowed to escape to go up front, leaving everything else behind. But then, once you had everything left behind, you had a 5 times 5, which 5 times 5 being 25, is a perfect square. And it is allowed to escape as well. That leftover 3, sucks to be him, is stuck inside of that radical and not allowed to escape. That is what these problems do. Now, on Friday, we are going to get some more practice with this material. I do have a quizzes lined up that we are going to practice with on Friday. And I am going to be assigning you some practice problems in regards to simplifying these radicals as we add to the information that we have already done. And we'll see where this takes us. Believe it or not, we are more than halfway done with this school year. We are more than halfway done with this school year. That blows my mind. It's either going to be that this half of the school year is going to fly by, or it is just going to drag. It is not going to be in the middle. That's what it kind of feels like. I don't know. It's just crazy. Anywho's, the bell is going to ring in approximately a minute and a half. Really a minute and a half. So I am going to end the stream here. If anybody in the stream has not commented yet, please make sure that you do. But I am going to be signing off on this thing. And we will see you next time. There we go.